All right, so thank you, everybody. Welcome to the office hours on cloud migration today. I only have a couple slides. This is not going to be a big slide presentation, and I hope that this will be very interactive. I don't have a lot prepared to say. We can hopefully this will be just more of a discussion. So I just wanted to first introduce myself for those of you who don't know me. So I'm a research professor in computer science at the University of Utah. And most of my experience with cyber infrastructure has come from building cyber infrastructure, mostly used by the computer science research community, but by some others as well. And I've been doing that since 2000. In addition to building cyber infrastructure, I also do research using it. And so, like, for example, one of the things that I've been most active in the last couple of years is doing research in performance repeatability. So you have a computer, a software system in your workload. You're running it on a hardware system, especially a large cluster, multiple times, right? You get variable performance results, and so a lot of my recent research has been around studying those performance results. And relevant to the topic of the office hours today, right? The performance variability is something that's even more of a big deal when you use, especially a public cloud, but private ones also can see quite a bit of performance variability as well. And then also, I am the PI of the NSF-funded Cloud Lab project. So this is a facility where people from the research and education community can come and essentially, the way that we describe Cloud Lab is that it isn't a cloud, it is a laboratory for people to build their own clouds in. So for example, we've had a number of cyber infrastructure type projects that have wanted to experiment around with some kind of cloud technologies that maybe their local IT department didn't provide, and so they've come and kind of built the environment that they wish they had in Cloud Lab, and use that to convince their local IT department that, well, if you build this for us, then then it would do what we want. It would perform well. It would allow us to store the information, the information, and process it the way that we need. So that's kind of enough about me. We had gotten a couple of questions that were asked ahead of time as people signed up, and so I thought what we could do is talk about these questions, and if the people who asked them are on the call, you can ask follow-ups and elaborate and that kind of stuff. And really, this is kind of the plan for the rest of the hour, right? Is to just do just have a discussion around these topics and others. So the first one up here talks about kind of the expense of the private cloud. I'm curious, do we have the person who submitted this question on? Please feel free, by the way, to unmute yourself at any time. Let's see. Okay, so we may not have the person who asked this question on at the moment, but let me go ahead and address it a little bit. So, kind of one of the things that this question gets at, right, is that the public cloud really is sold often as a cheap alternative, right, to having your own local IT. But really, the devil is in the details as far as whether anybody actually moving to the public cloud will actually see that see any of those kinds of benefits, right? The person who submitted this question, their experience is 5 to 10 times more expensive on the public cloud. I'm a little bit that sounds on the high side. But I think that factors as to whether using a public cloud or something more private and on-premises saves money. It seems like a dominant factor in this tends to be the elasticity of your workload, right? So The thing that I've heard from talking to various companies that are using or have, or mostly institutions, mostly universities, that have, are considering using or are using the public cloud, is that, if you have kind of a base load, right, a set of resources that you essentially need on all the time, right, the public cloud tends to not be a good value proposition for that kind of thing, right? It tends to be the case that, essentially what's happening is you're just sort of, giving a cut to the cloud provider, right? If you are in an environment where you actually do have an elastic workload, that's really where the cloud shines, right? Where, like I have, there are computing resources that, I need a huge quantity of, but only every, only one day a week, right? Or only, on an unpredictable basis, a couple of times a month, right? Another big area that we see people getting sort of unexpected bills from the cloud is on data egress, right? So, if you look at the pricing that you pay for virtual machines or for container services or for serverless, Lambda kind of environments, the prices for the compute side tend to be fairly modest, but a good a strategy they use for lock-in, right? And this actually goes to the next question on this slide as well, is that is that essentially you can transfer your data in for cheap or free, but then getting data out is very expensive, right? And so, I think one thing that that we see is that people do have trouble forecasting the costs of getting their data out of the cloud. So, if you're in an environment of a public cloud, so if you're in an environment where you can transfer your data in once, then, and leave it there, right? Then that's can be fairly cost effective. But, looking at data transfer costs out is a definite strategy you can use there. So moving on to the second question on this slide, there was, can you share good or best practices for vendor independence? First of all, let me ask, is the person who posed this question on at the moment? Nope. Okay. So, very often a thing that, organizations are worried about when they're looking at moving data from an environment that they control to, one that they don't, right? Such as, the public cloud, is that they, are worried, rightly so, that they'll be kind of in an environment where they're locked into using a particular vendor, and then, if that vendor does not have some other features they want, or if the vendor raises their prices or whatever, then they get stuck, right? I think, the best answer to this question is a somewhat unsatisfying answer, I think. But it's, I think it's an important one to keep in mind. So, there was a time when, Microsoft was famous for a strategy they called embrace and extend, right? Which is basically, taking the basic technologies that everybody was using that were common technologies and embracing them, which is a positive, and then, extending them in proprietary ways, right? Which is, a positive to begin with, but in the long run, often is harmful to the consumer, right? So, and this is basically the strategy that the cloud providers use as well, right? So if you stick to the most basic service offerings, right? If you, rent virtual machines, running Linux or Windows, and run your own services on top of them, right? Then you'll have a very easy time, moving from one cloud vendor to another. Kind of the more the deeper you go, right, into kind of the more advanced features that the cloud operators offer, right? When you get into the features that automatically run Kubernetes for you, or that do some other kinds of container orchestration, or serverless computing, that's kind of the area where the offerings of the different cloud providers, first of all, are not all the same, or some of them may not have some of these offerings. And in other cases, they may have the offerings, but they work slightly differently, and so you have to port from one to another. And so, as I said, this was kind of a disappointing answer, right? But essentially, the most base, the more you stick to the very basic features, the more that you'll have an easier time moving to something else. And the more you use the bells and whistles, which do have short-term benefits, to be sure, right? Assuming that they are what you need and that you use them right, then the harder time you're going to have switching to another vendor. Now the next two are about security, and I was going to see, do we have? Okay, we do not have Susan Sans on. We do have some members of the CICOE pilot team who do have experience, like specifically like with this, like with, for example, the specific NIST standard. We do have ones who are kind of familiar with more of the compliance things. And I had invited Susan to be on, but it looks like she was not able to make it. So I think for these questions, I will postpone at the moment and see if Susan's able to join us later, and maybe refer people to her, via other channels in the long term. So I think with that, I'd like to go ahead and open up the floor to other questions. I mean, one thing that I'm curious about is I would just like to hear, whether we have people in the room today who have, let's say, successfully moved, on-premise services into the public cloud. So let me open it up with that question for you guys. Oh, okay. So someone is telling me here, Steve Jacobs is telling me he can't unmute. Rajiv, can you help make sure that people have the right to unmute?
They should be able to unmute themselves.
Okay, well, let me see. So we'll look at that. In the meantime, let us know in the chat, and I will go ahead and manually unmute anybody who has to be unmuted. So Steve,
I
you should
see
be.
Steve is unmuted right now.
Well, I did that.
Oh,
okay. Yeah, I kept getting host is not allowing you to unmute.
Yeah, sorry. Yeah, I'm sorry about that. I maybe people were trying to be a little bit more talkative. Anyway, Steve, yeah, go ahead.
I didn't see raise hand as an option. I saw reactions for like clap and thumbs up.
Yeah, you're right. I don't see that either.
The raise hand.
Yeah, there's a pretty bewildering set of options in Zoom. And
I was going to say that on that NIST 853 compliance question.
Yep.
We've been looking at some of that for a project, and if you go to the various providers, they all have these pages that break down various compliance options based on the level of compliance you're looking at. So NIST 853 sort of roughly maps in with FedRAMP compliance, and FedRAMP's available in sort of low, medium, and high versions. And for the low and medium compliance pieces, which I think is the most NSF affiliated sort of compliance requirements, you can get options in the public cloud regions of most of the providers like AWS or Google's platform or Azure. The thing to watch out for, as you said, I think on another question about the independence, is when you start talking about some of the SaaS offerings like hosted database or that sort of stuff, you really have to pay attention to that compliance matrix to see if the service that you want to use is actually something that is accredited or has an accreditation option for the level of compliance you're looking at. Amazon seems to have the most complete list right now. Google's is pretty large as well. Microsoft is catching up. Oracle has almost nothing. It just depends on what you're looking at. And you also need to make sure that the hosting environment that you're targeting supports the level of compliance you're looking for, that you don't have to go over to GovCloud or something like that.
Well, and I'll say, more from a purely academic side. I mean, this is, we have been running into this kind of stuff at the beginning. We have our semester starts next week, and we run into a lot of this stuff with like FERPA compliance, right? And a lot of these essentially end up having an option where you pay more and somehow magically it's compliant. Not exactly sure how that works, right? But like we had to get our our G Suite license updated to be FERPA compliant, right? And our Zoom license updated to be FERPA compliant. And as a user of these facilities, right, it is not clear to me at all what happened, what changed when they became compliant, right? The license costs more, I'm sure of that. But
the discussion you're having around the best practices for vendor independence as well, I would say that in my experience, if it's something that's very important to you for your project, that I would start off using more than one vendor at a time. Because inevitably, no matter how much planning you do, if you're only using one provider, you're going to make assumptions that are going to bite you when you try to go to a second provider. Even something as simple as just authenticating, your automation to start up something. And there are multi-platform APIs out there. Like Apache has one called libcloud that's written in Python. But if you look at that API, you'll notice it's a multi-cloud API client, but it doesn't provide this abstract interface that just works at any cloud, because it's not really possible to do that. And Terraform is sort of the same way. The more you get into the details, the more you're doing things that are going to be specific to the provider. And a lot of that is not lock-in. It's just different approaches to doing things like load balancing or starting up instances or routing or any of those sorts of things. So I think fundamentally, you just have to make that trade-off of, is it worth the extra engineering time to do this in a sort of abstract way, or is it better to just use the things natively and then pay the price later if you want to move? It really just sort of depends.
Yeah. So actually, something that occurred to me, so since people are having trouble unmuting, what I'm going to do is I'm going to go ahead and, since there's only, 15 of us here, I'm going to go ahead and unmute everybody, which I think will not actually forcibly unmute you. It will just give you the option to mute or unmute yourself. So let me just go ahead and do that. Let's see. Okay, so let me ask. So, other follow-ups. What are experiences that people have had in successfully or unsuccessfully moving things to public cloud infrastructure?
We've been talking to different cloud providers about Neon. We haven't made any decisions yet, but that 5 to 10x pricing question, I agree, that seems high to me. I think that there's some costs that probably aren't being accounted for in that question, like facility costs, for instance. You have to pay for electricity and you have to pay for the place that you're putting the computers. And if you're in a situation where you're paying for that no matter what, that's going to be different than if you're paying for an outside provider or you're paying the direct cost.
And that's actually a really good point. I mean, so my experience as a at a university in a purely academic environment, right? I mean, for us, we kind of helpfully live in this weird, like, I don't know, economics free zone or something where like everything is really, all the prices of everything are very distorted. And so like, because the University of Utah has a big data center, right? And because I don't necessarily pay per kilowatt hour, right, for the power in that, right, that's one of the things that helps make it much cheaper for me to run stuff myself than to pay somebody else to do it. One thing, but just a sec before you go, Steve. So So it looks like I'm getting reports on the chat that like apparently my strategy of unmuting everybody didn't quite work. So please, if you have if you would like to say something, and I would encourage you to do so, just say something in the chat and we will unmute you. So Brian, would you like to be unmuted? If you would like to, go ahead and say. Go ahead and say
I think I'm unmuted now.
Oh, you are. Oh,
yeah,
hey,
yeah.
great.
All right.
Cool.
Hey, Brian.
I think I checked the right box.
Oh, excellent. Thank you.
Of course, I unmuted, and as soon as I did that, my dog started barking. So hopefully you can't hear that.
Of course. No. No,
but yeah,
a good job.
I would say, I mean, I definitely, people talk about the cost of the cloud, and if you're talking about replacing an academic HPC center or even just a highly utilized HPC center, I don't see the value in that. But there's a lot of value in saying, for people who, if you get a small grant, you get 30 grand to do some computational work, and you can't buy a cluster for that, or if it's only going to be available for a few months, the cloud is great for that. So we're making our software available in the cloud for that reason. So people with smaller grants can get stuff done immediately. And yeah, it's very useful there. And when you use things like spot instances or we're looking at prepaid instances and stuff, the cost comes down a little bit. So it's not too onerous. I'm not paying the bill, so I can say that.
Brian, one thing for us has always been the CapEx cycle for large equipment purchases like that. It might be cheaper to use your HPC center than the cloud, but how about replacing all the computers in the HPC center versus the cloud and getting the funding to actually write that check versus having an OpEx cost monthly? That's, I think, where the debate actually gets interesting in terms of cost. But I think somebody said in chat, Patrick, and I would agree, it's not, if you're looking at the cloud as just a cost savings option, it's not ever going to make sense. It's more the time to action and the time to deliver and sort of the agility that you can get. And, in the commercial world, your competitor's already doing that. And so if you're not doing it, they're going to get features out faster and their product's going to be better than yours. And, it sort of makes sense. Academically, it's a little different. And it depends on how quickly you need to be able to work on that grant or work on that program.
Yeah, and I'd agree with that, and I'd add to what Patrick said too, because he says, the transition from running a cluster to running in the cloud was fairly non-trivial for their researchers. One of our goals as providers of software is to actually make it easier. So we make CESM, a climate model. Porting that is non-trivial to university clusters, but we can provide a pre-ported cloud-based version. And so, you can say, oh, well, it could take us 6 months with our systems people to install this and get it tuned and working, or we can run it today. And that today factor is pretty nice.
I'd also say for something the scale of an HPC center, you should talk to the different vendors directly because they can work with you on pricing and egress and that sort of stuff.
I have a quick question, Robert. So this is Rick Benson from Iris, and we're thinking about going into the cloud from a facilities perspective, which means large data for long-term preservation. Who has experience with keeping data in the cloud, not just for targeted research, but for sort of long-term perpetual storage and continuing access kind of a thing? Is there?
I think it depends on how often you need to access the data. We have, I guess, about 1.5 petabytes up at Amazon right now, in addition to on-premise object storage. But the pieces we're keeping in Amazon right now are all Glacier Deep Archive. So it's basically just the administratively domain separated retention copy. So we have a strategy that duplicates and replicates all that data, but the concern is somebody can still go accidentally delete it. And so we keep that copy out there just in case there's an accidental deletion, we need to pull it back. So it's a lot cheaper, very, very, very cheap, in fact, to keep, but recovery is very expensive if you want to get it back out. So I think it sort of depends on what sort of data you're talking about and how often you want to access it, really.
Okay, well, if I can add a couple of textures to that. So functionally, we treat it like an active archive, which means that it's all basically nearline or real time. Mm-hmm. And there may be some, we haven't gone through the analysis of knowing what can be Glacier based, what is it that's hardly ever hit. But in most of our science, so we're seismology, it's typically almost always expected to be returned immediately. And I'm wondering about, and of course we only bring in about, I don't know, maybe 300 gigabytes a day adding. We have about 700 terabytes, but it's the egress that I'm most worried
Right.
about, because that's a big chunk.
Well, and in kind of the thing that kind of makes sense to do there, right, is either to kind of go all in and, you know, put all your data in the cloud and do all your processing in the cloud, right, or to use it I think it was Steve was just saying, right, you know, kind of as a backup to your online one. Because yeah, if you store your data in the cloud but you're still trying to process it on you know, your local HPC facility, or you have other users who are trying to process it on their own local ones, you know, you're just going to pay a ton for egress.
I mean, we're looking at this exact same question right now, because we currently have an on-premise object store holding all that data with a replicated copy. I just got a budgetary quote from the vendor that sells it, and it's going to be $2.7 million for the next one that we have to get, which is a big chunk of change. And we're looking at transitioning all that data to a cloud provider as opposed to keeping it on premise. I think the first question you have to figure out is, are you storing that data in sort of a POSIX compliant HSM file system or something like that right now? Or are you using like a web interface object storage pattern of access? Because that will greatly impact cost in terms of how the data can be stored.
Yeah. So the current is a file-based HSN, and we want to go cloud. I'm sorry, we want to go object oriented.
So if you want to go to object storage, then the next question is, do the file formats that you're using support an object storage methodology? So for instance, you can do range requests to read pieces out of the objects. You can write the entire object in its entirety when things go in. You don't plan on modifying objects after they're written or append to them. Are all those sorts of restrictions okay? That would be the next thing to figure out. And then how public is this data set? Is this something that you might be able to get Amazon to put in sort of their public data set program so you wouldn't have to pay egress for access to it? If you did that, would you be okay with users being restricted to directly accessing the object storage for the data as opposed to providing some sort of application interface in front of it? All those sorts of questions.
Yeah, so is that a pretty steep education curve going into that? I mean, analyzing the prospects for either target. I mean, did it take a lot? Steve, are you with Neon?
Yes.
Okay. So you've functionally gone through that already, right?
We were fortunate that we were able to put object storage in place before we started publishing any sizable data sets. So the data set retrieval is all done off object storage today. So that's helped. I don't think users are really aware of that when they access, you know, I think it's CSVs right now, but that's the way it's pulled through. I know in seismology, you all have some very specific sort of API level stuff that you have to deal with for the file formats, right?
That's correct. Yeah.
So that could impact things. But I would say, you know, for the size of data you're talking about, if you have a predictable growth pattern of data, which it sounds like you do, and if you have a somewhat predictable access pattern, like you know how much data is going to be coming in and out, you should definitely engage directly with the providers, because there's stuff they can do to sort of mitigate that cost. You know, our concerns that I've brought up in talking with them are remote sensing data sets that are the large majority by size of our data. And, you know, typically, I don't have the numbers in front of me. We have a predictable amount of download that comes through the data portal for people accessing data. But I also have facilities like the San Diego Supercomputing Center that want to mirror 700 terabytes of remote sensing data. And I did some, you know, quick math on Amazon's public cost calculator, and I figured out that download would cost me $180,000, which, and I can't predict when it will happen. And so if that's the sort of bill that I'm going to be faced with randomly when somebody wants to access these things, that's just not feasible, right? So I've brought that up with the providers, and they've been working with us to try to figure out a way to mitigate that. And there's definitely stuff they'll do, but they NDA it all, so I can't talk about it. But
yeah, sure.
One thing I will add is, so Brian mentioned in the chat a while ago that I guess AWS does have an academic egress waiver, and you might be able to
for I2.
Yeah. So I just have a quick question related to controlling the cost. How often do these cloud providers go through this sort of rejiggering of their cost center and cost analysis?
Usually the cost goes down. I don't think I've seen a use case where the cost has gone up because there's such high competition between the vendors. You know, when we looked at object storage at Amazon, 6 years ago, it was clearly cheaper to hold it on premise, just purely from a bytes per dollar on the storage, not even talking about egress perspective. And here we are 6 years later, and that's no longer the case.
Great. Thanks, Steve. I appreciate it.
So whoever has gone through this process of with Amazon for getting these waivers for academic and research access for data, do we know how involved this is? And because that's a very attractive option, right? Like for anybody who is considering moving to the cloud, especially in this academic research space, that would be a powerful thing. Is there any processes there? Do we know who to talk to?
Yeah, I mean, generally you start with your local representative, but the person who set this up was Kevin Jorison, who's basically the earth science guys at Amazon. And I can't remember the details of it's 15% of your total bill up to your full egress costs. But again, if you have storage or compute, it ends up that your egress might be minor. But the process seemed to, it was already done at NCAR, so I wasn't involved, but I was told it was pretty much just send a note, and if you're an EDU organization, then it's effectively send a note to your representative that it's done. Maybe they've made it more formal since then, but it's very easy. Yeah.
Right, because also from the NSF and right, we do have the ECAS program where NSF actually does it for the size community, but we can see in future that NSF also can play this role broadly across many other facilities and might do like a lot more consolidated leverage and negotiation with the cloud providers to do this, right?
Could you talk about that a little bit more? What do you currently do for size?
So there is a program at NSF called ECAS, and the project that's doing it right now is called the Cloud Bank Project. So what happens is the size researchers write these grants, and then instead of putting money, they actually ask for this credits from Cloud Bank, and then NSF goes to this the cloud providers, and basically it's kind of a consolidator for getting the credits for the individual researchers, size researchers.
And one of the things that does, by the way, it is kind of a little bit of a, I don't know, a hack to work around some awkward budgeting practices at the universities. So what happens is, so I have one of these Cloud Bank awards. So what happens is, as a PI, as Anirban said, that money essentially, it shows up in my budget. It just doesn't come directly to me. What it does though is that if I were to spend it out of one of my own accounts, then my university would probably charge me overhead F&A on it, and that would, and so it would be like 50%. I'd have to spend 50% more than it actually costs, right? Which is kind of ridiculous, right? Especially for cloud type resources. So the advantage in having this centralized within NSF is that basically, it doesn't increase the amount of real plus virtual dollars that I get on my award, right? It's still, like I said, it still shows up in my budget. It just doesn't come directly to me, but it gets essentially exempted from that overhead. And the amounts of dollars that they're talking about here are, I mean, these are for things that are, research projects that happen to, want to spend a little bit of time, do a little bit of compute on the cloud or something. So, we're talking in the thousands of dollars of credits. So, real amount, but kind of not large facility size at all.
Right.
So something I'd like to do, so we have earlier on, I mentioned that, we have a member of the CICOE pilot team, Susan, who has a lot more experience with, things like regulatory compliance and stuff. And she's now been able to join us. So Susan, would you mind saying kind of a few words, about like the NIST, standard that's mentioned here?
Sure. So first of all, 853, figure out if you're required to deal with 853 compliance or not. Because one thing is, we have some institutions that thought that it was just a security standard you should follow and not a government compliance regime, because 853 was written for government agencies. It's not always a great fit for open science. So we use it when we're contractually bound to, but if you are not contractually bound to use it, it's not a great guide for your cybersecurity, because 853, for example, pays a lot of attention to preventing data exfiltration and preventing compromise of credentials, and zero attention to data integrity. And as scientists, we care a lot about data integrity, because if our data is no good, our science is no good. Whether we care about confidentiality or not varies incredibly from project to project. I have some projects that publish all their data the second they get it. And if you say that you want to take all their data, they try to take you out to lunch and explain their data more and get you to listen about their data. I have other projects that have temporary embargoes, and I have other projects that have some public and some confidential data. Our level of care about confidentiality is variable, and our level of care about integrity is always very, very high, which makes us a tough fit for 853 in terms of matching our real cybersecurity needs to this particular compliance. But when you got to do it, you got to do it, because funders get to make rules for us. So first of all, don't do it if you don't have to do it. If you do have to do 853 compliance, try to get someone who is a compliance expert on your side. We have somebody in my shop, Anurag Shankar, who just lives and breathes this stuff, and I love having him around, because while as a CISO and a security analyst, I have to deal with compliance pretty regularly, it's nice to have a specialist who knows the ins and outs and knows what does and doesn't get enforced when the auditors show up. Because like anything, it's open to interpretation. Those things said, which are kind of my warnings about the environment, when you are selecting cloud environments, one of the biggest things is negotiating your contract with the cloud provider, because if they have not promised to do something in a written contract, they're probably not going to do it. And even if they are doing it, when you go and do your compliance audit, if it's not in a contract that is legally binding, you can't take credit for the fact that they're doing it. And that's really a pain, because the auditor's afraid that they're going to stop doing it at any moment. So you want a commitment from them to maintain certain standards. And that's one of the biggest things when we're moving out to cloud systems, is what do they have a responsibility to keep doing and do correctly over time? And that's hard for tech people, because the thing that at least I like least is dealing with contracts. I don't know about the rest of you. Maybe some of you are secretly lawyers as a hobby, I don't know. Apart from that, the actual nut and bones of compliance is either implement the control they want, or come up with a good reason why you didn't and document the controls you have in place instead. This is a documentation practice more than it is a security practice, and you can get through it. Beginning to end, it's actually not hard to be in compliance, frighteningly enough, whether or not you are secure. The big deal is knowing your assets and knowing what controls you really have in place, and keeping your documentation up to date at least once a year. If you sit it in a drawer and don't update it, you're going to end up out of compliance. Apart from that being the general overview, I'm really happy to answer specific questions, but since I don't know what this group is most concerned about, I'm not really sure where to go next.
Yeah, and it seems like we have some of the people who asked some of these questions on here, and some, and not everyone. So I don't know if we have the specific person who asked about 853 compliance. If you are there, would like to follow up more, please do. Okay. Well, thank you very much, Susan.
Han.
Yeah.
And, oh yeah, Rob, just wanted to let you know, just
Yep.
give you a 10-minute warning.
Yep. Thank you. Yeah. I was gonna spend that last 10 minutes just kind of, continuing to open up the floor to questions. I'm curious. We've heard from a couple of people who are using the cloud for various things, and a couple of people who have questions about using it. I'm curious to know whether there is anyone on here who has like tried to move stuff to the cloud, or started to move stuff to the cloud, and then had to give up or abort on that. Nope. All right. Well, I guess those of you who have tried have done a good job.
Kind of disappointing. I was actually hoping to hear somebody having some struggles. I would have liked to have heard a type case for just what the push point is. What is the bailout line in the sand?
Yeah. I mean, I guess I guess I can tell a story along those lines. It's not my own story, but I had a student who worked for a pretty major like biotech startup company, and essentially, I forget which was which, but essentially they started on, I think, AWS. They had a whole bunch of data stored there. And then, either through some management decision or because of some new feature that got rolled out, or maybe some pricing on some of the compute stuff, they decided that they were going to do their compute on the Google Cloud Platform. And so at the time that I was working with the student for a period of a couple months, they were essentially doing most of their computing on Google Cloud Platform, pulling data over on every job from EC2. And I guess, when you're a startup and have venture capital money to burn, I guess this is something you can afford to do. I would, constantly hear stories from him about, how much more they were spending on, moving the data back and forth between the two. So I think, earlier on, Steve gave the advice that, if you, really care about being vendor independent, that you should start with, using two vendors to begin with. I think, one thing I'd like to add to that is you probably have to be kind of smart about how you use the multiple vendors. And this particular company was not, right? And they were sort of essentially using these two vendors in the least cost-effective way possible. But so probably, a lot of that, means using essentially using them in parallel, not in tandem, right? I'm guessing is kind of what you had in mind there, Steve.
Yes. or also what I had in mind is try to do it, and then you'll probably end up with one.
Right. You might find that one of them is harder than the other or more expensive than the other. Yeah, that's probably true.
I have a quick question. This is Rick Benson again from IRIS, wondering about sort of migrating large volumes of data out of a cloud environment to sort of a tiered facility, or a co-located facility somewhere off-site, and sort of what the limits are. I mean, can you do big data? Can you do basically hundreds of terabytes?
Yeah.
This is actually an interesting question that maybe somebody else has experience with this, but one thing one service that I know that a lot of these places have is, to get data in, you can ship them drives, right? I actually don't know if any of them offer the reverse property.
It's a bit better than that now.
Okay.
The most mature of those offerings is definitely Amazon's Snowball series of devices.
Yeah.
So what they'll do is they'll ship you a box that has like an e-ink display on it that You can either pre-load with data, or you can load data into with the same APIs and keys that you use in their cloud services. And then it just gets mailed back. And I think, I don't know what the current sizes are, but I think it's like 400 terabytes a box, something like that in the larger config. And then for really, really, really big migrations, they actually will back a semi up to your facility in the same sort of way. And that can be used for ingress and egress. So in cases where, you know, egress bandwidth would be very expensive, it can be a lot cheaper to have them ship you this box that you can keep for a bit and then take it up. You can also do some local compute and things on it as well, but for ingress and egress, just look up their Snowball devices. GCP, they offer basically just mailing a NAS type device back and forth. The disadvantage to that is if you plan to leverage any of the sort of tagging or extra metadata facilities you can do against the object storage, you have to do it after the fact with their APIs. After you send the data, they don't really provide a native you know, version of their object storage on that box. It's mostly just for transferring raw files back and forth. And I believe Amazon has a similar offering. I just haven't investigated it. But you absolutely can do that in sort of a faster version than doing it online. But like Robert was talking about earlier, in terms of getting data in, there's no ingress charge for bandwidth. So if you have the bandwidth available, you can use a tool like rclone or something along those lines. It's kind of like rsync for object storage to copy that data in. And that works as well.
Yeah. So the other options in this space are, say, the Express Route or Amazon's Direct Connect, right? And then the another interesting thing that's happening in this space is Internet 2 is having these endpoints where Internet 2 is negotiating with these multiple cloud providers, and you can set up VLANs to your co-location or to your on-prem. Setting up that path, that circuit is a different story. But if you have Internet 2 endpoints, it's quite easy in that sense. So the cost is mitigated in that sense because the rates for both Direct Connect and Express Route are less. And then even for Azure kind of for Azure Express Route, there's even unlimited egress. If you do that, of course, there's a cost, and it's about 7 or 8 times the cost if you don't have if you have a metered egress. So there's another set of options on the table for the same thing.
All right, and I think we're about out of time, so I think egress is probably a good place to end to leave. So thank you everybody for coming, and I really appreciate all of the, you know, both the questions and the answers that some of you have been able to provide. So thank you. Enjoy the rest of the workshop. We'll close this down in a minute. Susan has been typing some stuff in the chat about some of the security standards. And Susan, you might want to move those to Slack before this room vanishes and we lose them forever, right? But you know, please do continue to follow up on Slack, and I hope you enjoy the rest of your day. All right, well, thank you, everybody.